Well, considering I'm fairly long-winded, I got rudely cut off by my program. So we're going to pick up where we left off. I've got about 3 slides left. So with these energy levels, we said those are the different locations or regions. Remember, orbits was the Bohr model, but they're not really orbits that electrons can have around a nucleus. Ground state, they are all at their lowest possible levels, and it's energetically stable. If electrons absorb energy from a heat source, from electricity, those electrons will move to higher energy levels, which makes them further from the nucleus, and we consider that an unstable state. So, in terms of the flame, the first thing that happens is some of the heat causes the electrons to jump energy levels. They move away from the nucleus. You can't actually see that happen. There is nothing visually showing that happens when they first gain the energy. You actually see the release of color when those electrons begin to fall back down to the ground state. So at the excited state, the energy is in terms of the electrons, and when those electrons release energy as they fall back to ground state, that's when you get to see the color. So here are a few different examples of emission spectra for some particular elements. Hydrogen, remember, has only one electron in a neutral atom, so we see far less lines because there are less electrons moving around. There is still more than one, though, because the hydrogen, depending on how many quanta of energy it absorbs, can jump more than one energy level. Sodium, having only 2, what that suggests is that some of its emission might be outside the visible spectrum. Remember, it doesn't just have to be in the colored regions. But the variation you see in these different samples is because there are different electrons jumping different energy levels. And again, when they fall back down, that is when you see the specific patterns of light energy released in different colors. The color indicates the wavelength and frequency, and those are an indication of the amount of energy. Violet, higher energy waves. Red are the lower energy waves.